Okay. So Allison's a little bit ahead. It would be better for all of you for learning to do what we've done before, which is read slow, raise your hand when you identify first thing of note. So, keep your hand. Ashton.
It's a velocity graph
Outstanding. Oh, be careful.
or table. Okay.
Yeah, perfect. So the table is definitely velocity. Very important to note that. I've never seen a problem where you would not want to pay close attention to that fact. Somebody else, keep reading slow. All right.
Well, the table is the derivative of the graph.
Perfect. Also, never seen where that would not be important. So the derivative of this is the table. Perfect. Someone else. Okay, and just a comment. That's how you solve AP problems. You don't solve it by saying, hey, I've done this one before. You just keep finding connections. Eventually you'll make enough connections that you'll have that amazing experience Kennedy had where you go, I see it now. I can see how it fits together. But you just have to keep plugging away. Liv.
Is it the derivative because the graphs are position graphs and then the first derivative would be a velocity? Because it goes position, velocity, acceleration.
Mhm.
Okay.
Okay, say it better.
That's why.
Perfect, yeah.
So I was like, I don't see it anywhere in it that says why.
Makes longer sense.
It's like, yeah.
Kennedy, I have never ever had a student, no matter how hard calculus was, ever say they didn't love the feeling when it starts to make sense. Like, no kidding, like it just feels great. So,
Keep on going.
yes, please, Quincy.
Okay, it says at time equals 0, the particle is at the origin. So does that mean that you can automatically eliminate B and D because it doesn't start at 0?
Perfect, perfect, perfect. Want to make sure everybody understands like something that has been a common error though. And you guys were fine, I wasn't trying to interrupt you or anything, but please remember, this is a graph of the position. It's not a picture of the particle's motion. If I want to draw a picture of the particle's motion, I draw this. And this shiny, glow-in-the-dark green dot is the particle. So this is my picture of the particle's movements. But when you take this information and want to make a graph of it, you've got to assign, let's see, we say, okay, we've got time and position. And according to this, when the time is 0, position is also 0. If you want to put that on a graph, it has to look like that, that, or that. It cannot look like this. We want to talk more about that idea. Splendid. So somebody else, what else do you have as far as read and find clues? Please.
Oh, me?
Yeah, you raised your
Okay,
hand.
sorry.
That's awesome. You're very polite. You're just waiting to see if somebody else.
So I know that it says, oh, where'd it go? So I know that since it's going from like the T graph, the time graph is going from, it goes negative to positive to negative. So like, I know that it's gonna go concave, wait no. Yeah, concave down, no, down.
Okay, I want to interrupt you just a second. Allison.
Decreasing to increasing to decreasing.
I want to interrupt just one thing. Don't do that. I was searching for like the most polite way possible. And the best I could come up with was like, no. Sorry. Appreciate that you laugh, at least it makes me feel better. Like I try so hard to be nice. I try really hard. So, yeah, the table gives, what's the magic word again? The table always gives
Selected values.
selected values.
Yeah.
So you got to be careful about trends. That doesn't, Allison, doesn't mean there aren't some, but I just want to be really careful about looking for trends in a table. Okay? If I don't have some more information, I just got to be really careful about that. So initially, I'm not going to look for trends in a table.
Okay.
Point to point is fine, like before we used a table to find a secant slope, that's definite.
Mhm.
You find a secant slope from point to point, that is absolutely the secant slope. Nothing wrong with that at all.
So I can't cross out A because it doesn't go negative, decreasing to increasing. It just starts increasing.
Well, the other problem is you're kind of paying attention to the velocity graph going, I'm not sure, are you saying, I see, you're saying because the velocity is negative, back up. If we go point by point, it works great. We just don't want to go continuously.
Yeah.
So we want to say at time equals 0,
Yeah.
just at that one time, the velocity is negative, so what must the position graph do?
Decrease.
Decrease.
Sorry, that's what I was trying to
Oh,
say.
you're fine then, you're fine. Does that make sense?
Yeah.
Does that make sense to everybody else? That's how she eliminated A, and that's perfect. You good?
Yeah.
Awesome. So we got rid of A, we only have 2 choices left.
Now what do we do? That's the question.
Go to another point. What's happening at time equal 1?
It's positive.
Don't
so
say it, though it's offensive.
Oh, dang it. The velocity is positive, so it can't be E because velocity is negative at point 1 on graph E.
So the velocity is the tangent slope of the position. Must have that memorized. That's what Liv was doing a minute ago. The velocity is the tangent slope of the position. So this says on the position graph, at time equal 1, tangent slope should be 2. Time equal 1. I don't know if that's 2 or not, but at least it's positive. Time equal 1, that slope is not positive.
Yeah, so you can cross it out. I get
Wow,
it.
that was mad.
That was rough.
It's, how do I say it? There are many AP problems that require, there's not like a bunch of computations to perform. It's a bunch of connections to be made. You
Never
just
one
make the
connection.
connections, you're good. What's that?
It's never one connection, it's like 5 of them put together.
Yes. Yeah. That's also usually new for people, because they're used to questions like, oh, it tests one idea. No, they make them test 3, 4, 5. 22.
Sorry.
Good job, Mark.
And you have to go to work.
You're good. Where do you work?
Rad swim.
Where?
Rad swim.
Rad Swim.
Flyers.
What's Rad Swim?
Swimsuit.
Oh, it's a swim shop. Like,
Yeah.
okay, gotcha.
Yeah.
4 of my 5 kids were swimmers. That's why it was
Oh.
what Rad Swim was.
Yeah.
Very nice. Awesome. Okay. Which one?
22.
22. Anybody else want to talk here? Good job, Chris.
Thank you.
Good job, Ari.
Yeah, I just, oh, never mind, sorry, keep going.
No, I just had a question if you have any other practice tests at all?
No, it takes a lot of time to get a good practice
I would assume,
test.
yes.
Yeah. You can tell by the type of problems, right? So I
Yeah.
apologize I don't have more
No, that's
for you to
okay.
practice.
Do you have like a recommendation on any other problems that we can like go
Um,
through? Would you just keep going through these problems or?
I really think the 50 that I've given you are sufficient
Okay,
as long as you keep reviewing them, knowing why you did each thing.
okay, yeah.
So what I would do when I was in college, are we done with this one, everybody? Anybody want any more here? Stop the recording.